Alright, so we have a problem here about vectors and how to find a perpendicular vector that's also 1 unit long. So the question says to find a vector of unit length in the xy plane that is perpendicular to 3.1 I hat plus 4.3 j hat. So I don't have to do this, but I'm going to sketch out this vector because it will clarify some of the things that I'm talking about. Two, three, four, 5. 2, 3, 4, 5. Alright, and this is the x-axis and the y-axis. So our vector to begin with, let's remember that this vector I hat is by definition 1 unit long and it points in the positive x direction. The vector j hat also by definition is 1 unit long and it points in the y direction. Okay? So when we go in here and we say that maybe I should redo that. Okay. So let's call this our vector v is equal to 3.1 I hat plus 4.3 j hat. Alright, so when we say we have this vector and it's broken in down to an I component and a j component, what that means is if we took 3.1 times our I unit vector, that unit vector was 1 unit long, so 3.1 times that is going to be 3.1 units in the positive x direction. Okay? And similarly, if we take 4.3 times the j, that was 1 unit long, so it will be 4.3 units. 4.3 units in the y direction. And then our vector v can be found if we determine where these two vectors will cross. So we extend some perpendiculars to figure out where they cross, and that will give us the length and the direction of vector v. Okay? Now what we're asked to find is a vector that's perpendicular to our vector v. And just by sketching it, basically it's going to go in this direction or this direction. We'll work out exactly what that is, but there's two directions it could end up going in, and only two because it has to remain in the xy plane. So we don't really care. It doesn't specify which direction that it has to go in, which of those two. So we can just start working it out, and whatever direction we end up in will be good enough, I suppose. So we know by, let's call our perpendicular vector vector A, okay? So A is the perpendicular vector, and we know that if we have vector v and vector A perpendicular, that the dot product of those vectors has to be 0. Right? If they are perpendicular, the dot product must be 0. And let me go ahead and specify here that this A is equal to AX I hat plus AY j hat. We don't know what the components are, but there's something. So let's just go ahead and carry out that dot multiplication. Vector v is 3.1 I hat plus 4.3 j hat. That will then be dotted with AX I hat plus AY j hat. I just want to erase this, it's bothering me. Alright, so the way dot product works is you take the x components and multiply those, and then you take the y components and multiply those, and then you add the results. So this times this, so it's 3.1 ax plus 4.3 times ay. Remember, we want this to be perpendicular, so therefore that has to equal 0. I'll put an equal sign here. So we have two unknowns, but the thing is, again, we don't really care that much about whether it ends up going this direction or this direction, and ultimately the length won't matter because we're going to make it into a unit vector anyways. So we can just choose one of these pretty much randomly. We can choose AX or AY, and then we'll solve for the other one after that. So I'm going to choose AY. This will work, by the way, unless you choose one of them to be 0. If you do that, you run into problems, because you can see, like, if I said AY equals 0, then this would be 0, and then solve for AX at 0 too, which a vector 0, 0 doesn't make much sense. So I'm going to choose AY to be something that I want it to be, just not 0. Whatever other choice will work. So I'm just going to make the choice AY equals 1. That's a pretty simple number. So then I get 3.1 AX plus 4.3 times 1, because that's just 4.3, right? Equals 0. I'll solve for AX, so we get 3.1 AX equals negative 4.3, and then AX equals negative 4.3 over 3.1. And let me simplify that. So negative 4.3 over 3.1. It ends up being negative 1.38, and I'm going to leave it there. Negative 1.38. Alright, so our vector A is then equal to negative 1.38 I hat, because that was the x component, plus 1 j hat, which is what we chose for the y component. This vector should be perpendicular to vector v. Let's sketch it to see if it at least looks somewhat perpendicular, okay? I want to be a little convincing here, at least. So minus 1.38 in the x direction. So it's going to be here and then about a third of the way. And then in the y direction, it's just going to be positive 1. That's easy. We're going to look for where those cross and give that vector, oh, wrong direction, right about there. So that's vector A. It's our vector A. And it's a lot shorter, but we don't really care about the length. What we want to know is that this direction is, this angle is 90 degrees, and at least with a cursory glance, it looks like it's perpendicular. Not that this is an exact diagram, but they look perpendicular, so it should have worked. And of course you can check again, if you were to dot multiply this by our original vector, you should end up with 0. Now it's not unit length, it should be longer than 1 unit, because the y component by itself is a unit long, so it has to be longer than 1. We want it to be shorter, so we're going to find a hat. Now a hat, by the way, if you didn't know this, just means a vector in the direction of A that's 1 unit long. So actually I hat and j hat, we're just saying that these are 1 unit long, and they're in their given directions. So, not necessary to write it like that, but it's a nice thing to know, I suppose. It will be equal to vector A divided by the magnitude of vector A. Let me start by calculating that magnitude. It's might look a little complicated, but it's really not. All you have to do is the square root of the components squared. So minus 1.38 squared plus 1 squared. You add those together and then put them under a square root, and that will give you your magnitude. Minus 1.38. And I do want to make sure that ends up in parentheses because it's a negative. So you want to square out that negative. Plus 1 squared. So it ends up being, it has a length of 1.70. Okay? So to find A hat, it's going to be equal to vector A, which is minus 1.38 I hat plus 1 j hat, divided by the magnitude, which we found to be 1.70. And like any other division, since there's an addition sign in here, we can break it up into separate pieces. So it will be minus 1.38 I hat divided by 1.70 plus 1 j hat divided by 1.70. And the I and the j don't do anything to the division. We're going to just divide 1.38 divided by 1.7. And that's not the I hat, you just kind of carry it along through the multiplication. It won't do anything to the division. So it's just a direction indicator. It's not something that will typically affect your calculations. Although in certain other types of, never mind. I mean, when you get into other subjects, you can actually like cross I into j, but we're not going to worry about that right now. Okay. So minus 1.38 over 1.70. So it's minus 0.811 times I hat, nothing happened to that, plus, and then it'll be 1 over 1.7. 1.70. So that's 0.588. And I'm going to do one more thing with this. I'm going to switch this down to just 2 significant figures. And the reason I did that is because if we look at our original information, those were both 2 significant figures. So I want my answer to be the same. With this. Alright. That vector has 1 unit in length, and it's perpendicular to vector v. So essentially it would look like vector A here, but let me choose a color. It would be shorter. It would be something like this. Just a short little vector, same direction as A, but only 1 unit long. And just in case, you don't have to do this, but if you want to check that really is 1 unit long, all you got to do, I'll stick with that color. You take each of the components, square them, and add them together. Again, this is similar to finding the magnitude of this, just like we did before. For that vector A, we're going to do this for vector A hat. And we get that minus 0.81, that's 81, squared plus 0.58, or it was 59, wasn't it? 59 squared ends up being 1.004. And that's approximately 1, right? It's not exactly 1 because we rounded off our answers along the way, but it's very close. So there you go. That's how you can figure out your 1 unit long perpendicular vector. If you wanted the vector in the opposite direction, so we found one in this direction. If you wanted the vector that went in this direction, it's just a matter of picking your component, this component that we choose. So I chose this, and notice it's positive, which means it's going to go up. If I had chosen that negative, I would have got something in the other direction, of course. So you can get either direction if you want to do that. I hope that helped, and if you have any questions about what I did here, feel free to ask, and I'll do my best to get you an answer.